In this short video, we want to look at the psychometric process of mixing two air streams. So a nice example for us is, imagine you had a mixing box on an air handling unit. We have some outside air that's coming into the building. It's in the summer, so it's hot and humid, and we have return air from the building that's relatively cool and dehumidified. These two are going to mix in the mixing box, and we're going to get air at a different condition, something that's in between the two. And you can clearly see that on a site chart, or if you're using a piece of software that allows you to mix two air streams. But this is we're just going to walk through that process. Well, let's start with our outside air up here. And in this case, our outside air is going to be very warm. These vertical lines that you see here are the dry bulb conditions on a site chart. So this is 95-degree dry bulb air. It's very warm. And then these 45-degree style sloped lines here that you see, the blue ones, the 70 and the 60, this is the wet bulb. And so you'll often hear outside air is described as being 95 dry bulb, 78 wet bulb. And once you have two properties of air, you can plot yourself on the site chart. You can see we position ourselves right here, knowing these two conditions. And you'll see that we've also called out another one with this horizontal line. Now these horizontal blue lines you see here, the 140, the 120, the 100, they're a measure of how much mass of water vapor is mixed in with the mass of air. So it's a ratio. And the way we talk about it is we talk about grains of water vapor per pound of dry air. And why do we use grains? Well, grain is just a unit of measure of mass. There are 7,000 grains in a pound. So you could use pounds over pounds, but the numbers are and you can see that on a lot of site charts, but you'll get a very, very small ratio. So you just need to look to see which units of measure are being used on your site chart or on a piece of software. And now this is very hot and humid air. This is a summer design condition, so there's 117.4 grains of water for every pound of dry air. And so this is going to, as this air is brought into the building, it's going to introduce a lot of humidity to the building. Well, let's go look at our other airstream, which is down here. This is the return air in the building. And unless you know otherwise, a good place to start is to say that the return air should be pretty close to the design supply air condition of the space. And so that's often you'll see it described as 75 degrees, and we usually say 50% RH. So you see these sweeping curves here. These are what relative humidity lines look like on a site chart. So that's 20%, 40, 60. And you can see that dot is kind of halfway in between. So this design condition is 50% RH, 75 degrees dry bulb. The wet bulb is 63. And again, our humidity ratio, which we talked about before, is 64.6. These are kind of the standard design conditions for commercial HVAC systems for the interior space. Often these numbers are used for everything. So we have, notice we've drawn a line between the two. What happens when you mix airstream, and we're going to mix 50% outside air with 50% return air, is you have to land somewhere on this line. And so if you have mostly outside air and a little bit of return air, you're going to be very close up here. You'll be somewhere on the line. If you're mostly return air and with a little bit of outside air, you're going to be down here. But whatever the condition, whatever your ratio of the two airstreams is, you'll be somewhere on the connecting line. So in this case, we said we were going to be 50-50. So it is literally right in the middle on this line. So we split the difference. And so let's look at what's happened here. Let's start with the temperature, right? We had 75-degree return air. We had 95-degree outdoor air. It's a 50-50 ratio, and so the mixed air is going to come in at 85 degrees. So you can see it comes straight up, and you can see that visually that we've split that line in half. Over here on the wet bulb, it's very close to the same thing. There was our wet bulb is coming in at 71 degrees, and it's almost halfway in between these two. These lines aren't perfectly parallel. If you use software, you will see these things, and you're measuring to 1/10 of a degree of F, you'll realize you won't be exactly 50%, but it's because the formulas aren't exactly linear, and the software is just doing it to a more accurate number. And then the important part over here is we've split the humidity ratio, right? So again, you can see that we've landed almost halfway in between. And between these two, This mixing box that we're imagining this process happening in, you can see we're now going to introduce a bunch of moisture to the building that's going to have to be removed by our cooling coil, or we're going to start to raise the humidity in the building, which will not be satisfactory to the occupants. So that's how the mixing process works. Just remember, plot your 2 points of your 2 air streams, draw a line between the two, and then you're going to be somewhere on that line based on your actual mixing ratio. Well, I just want to show another common condition. We're still in the summer, and I'm going to use 8067. If you look up a lot of HVAC equipment that's been tested to an AHRI standard, they have to pick some kind of design condition. If you buy a 10-ton packaged rooftop unit and they say it's 10 tons, 120,000 BTUs per hour of cooling, when you read the selection, it's going to say that was based on a mixed air condition of 8067. That number is a good national average for North America. It wouldn't be right in Florida or necessarily, or Chicago or Fairbanks or Phoenix, but you have to rate the equipment at some condition. And so let's just understand what that would look like on a site chart. So again, we have our return air condition of 75 degrees and 50% RH, so we saw that before. We have this outside design condition that we used before. And we're going to look at what 8067 looks like. So 80 degree dry bulb comes up to here, 67 wet bulb. And you can look at it, and what they're really saying here is, for a typical piece of equipment, we're going to be roughly 75% return air and 25% outside air. Now, if you live in a part of the world where this isn't your outside design condition, and you move down here, or if you're in a desert condition, you move out this way, this point is going to change a little bit because it is the mixed air condition. But I just wanted you to understand where this 8067 comes from and why a lot of equipment is rated at it. Kind of typical conditions for North America. Well, we talked about summer conditions. Let's do the same thing with winter conditions, but now we're going to turn the question around a little bit. Consider an air handling unit where you have a mixing box on it, and that air handling unit is supposed to deliver 55 degree air to the space. So it could be a VAV air handling unit on a typical project, and you have this opportunity of mixing warm return air from the building, right, with outside air. And so this time we're going to ask the question the other way around, which is, if you know you need to be at 55 degrees, what's the mixing ratio that you need to deliver 55 degrees? So let's look at our conditions. We're starting here with return air. It's going to be a little bit cooler now. It's 72 degrees because it's winter. Notice the humidity. These arcing lines here is 20% RH, pretty typical for a winter climate, winter condition, and that our wet bulb is 52 degrees. So that's our return air condition. Our outside design condition is 0 degrees. And if you started following these lines down here, you would realize that we actually have a very high relative humidity. In the dead of winter outside in a cold weather climate, it's not unusual for the relative humidity to be 80 or 90%. But it's 90% of the amount of moisture that air can hold. And you can see this curve being our saturation line actually doesn't have a lot of humidity in it overall. That air is cold. It won't hold very much. So if you get a little bit of water vapor into that air below freezing, you'll very quickly come close to saturation. That's why your relative humidity numbers are so high in the winter. So we have this condition. As we saw before, we can draw a line between the two processes in here. We've called out freezing, 32 degrees, because that's a lot of interesting things happening here. If you have condensation below this condition, that condensation will quickly turn to ice. And our goal here is to mix to 55 degrees, which is right here on the site chart. So let's have a quick look at that. So now we're going to introduce this mixed air condition. Remember what your building automation controls on that air handling unit are going to do. They're going to play with the dampers on the mixing box, and they're going to allow some outside air in and some return air, and the controller is just going to play with the two dampers until it sees a mixed air condition of 55 degrees. And our question here is, okay, when you do that, how much of this is going to be outside air and how much of it's going to be return air? And so we can do a quick calculation here. We could do this by looking at any of the properties. We could use the dry bulb, we could use the wet bulb, we could use the humidity ratio. I'm just going to use the dry bulb temperatures because it's fairly easy. And we're really just calculating a weighted average, right? So the difference, the length of this line here from 72 to 55, that's our numerator, 72 to 55, over the whole change from 72 down to 0, right? And what we're seeing here is that it's 0.236. So this requires 22.3% of outside air to cool the return air, the 72-degree return air, down to 55. We would mix in 23% outside air because it's cold. Now, as the weather warmed up outside and you moved away from a design day, maybe 25 degrees in here, you will need more outside air and less return air, and you could, again, recalculate the conditions to come up with the new ratio. The classic thing, of course, is when it's 55 degrees outside, what you go to is 100% outside air, right? You just bring the outside air in at 55 degrees straight into the space, and you don't use any return air, so that air would all be exhausted out of the building. So that's a quick lesson on how what happens psychometrically when you mix two air streams, a very powerful tool for a lot of HVAC processes. Thank you for listening.